Magali. I'm an undergraduate student currently in my midterm exam, so it's really intense. I will show you my honor thesis that I've done with Emmanuel Pelletier under the supervision of Guillaume de la Fontaine at the University of Quebec in Rimouski. Since English is not my first language, it would be easier for me to talk about my favorite color, but today I'm going to talk about the role of intraspecific variability in the long-term persistence of rear-edge jack pine population. So let's start. Marginal populations are often at the limits of their physical tolerance. Conditions that are not suitable for the species will become widespread within climate change, resulting in increased evolutionary pressure. Because marginal populations lie at the ecological and geographical forefront, studying their dynamic will aid conservation effort and improve forecasting accuracy. So the main goal of our study was to gain insight on the potential role of intraspecific trait serotiny variability on the persistence of marginal population at the rear edge of its distribution. So we use jack pine as a model. Jack pine is serotinous and is a shade-intolerant species. Serotiny is defined as the prolonged storage of seed in mature cone retained in the canopy. It is the most prominent adaptation of jack pine to recurrent fire. In fact, jack pine is an obligate periscent species, meaning that the seeds are only released when high enough temperatures are reached to melt their protective resin layer around the cone. Indeed, jack pine is commonly found in monospecific even-age stands, where the unique cohort dates back to the last fire event. Variability of serotiny level have already been observed, but here we went a little bit further by linking the variability of serotiny level and fire regime to the geographical setting of the stand, so core versus edge. Our main hypothesis is that the rear edge stand have a lower mean serotiny, but high intraspecific variability due to the rare and unpredictable fire event. It is expected that a variation in serotiny will promote long-term persistence when there is no fire. So population with low or variable level of serotiny can be characterized by uneven age stand structure with steady regeneration. In contrast to highly serotinous population should follow an even age stand structure without recent regeneration. So we sample 26 stands in 3 different fire regime area, 17 at the rear edge and 9 at the core of the range. To establish the stand size structure of each site, we measure the dBH of each tree and sample the sapling and seedling in a quadra of at least 500 meters square. So stand level mean serotiny of each site was estimated by assigning 100 jack pine individual per site to one of 6 serotiny class. We then use those data to compute a mean serotiny per site. 10 of the largest jack pine were core to mean the minimum age of each site. So here we can see that our site at the rear edge are smaller. I don't have a pointer. Okay, are smaller and are more isolated than the population at the range core. Also, the landscape is less occupied by jack pine at the rear edge than at the range core. When we look at the fire frequency, the fire frequency is smaller at the rear edge than the range core, and it's only from entropic ignition compared to the range core, where it's also a natural ignition. So our first result, rear edge stands are less serotinous than the range core. So all along my presentation, rear edge stands are dark pink, and range core is light pink. Here at the right, we can see that we put the coefficient of variation in correlation of the mean serotiny. So we can see that population with a mean serotiny smaller, lower, have a higher coefficient of variation than the population that are strongly serotinous. So that means that the mean serotiny have more variability of level of serotiny in the stand than when the mean serotiny of the stand is higher. So therefore, there is a high number of partially serotinous individuals at the wire margin, indicating the opening of cones and recruitment without fire. So after we fitted our empirical tree-size structure data of each side, like we can see at the left, with a quadratic curve in order to observe the overall demographic pattern. As the ecology of jack pine, it is expected to see an even age size structure described with a hump shape, so a monospecific cohort dating from the last fire event. But here we can see two patterns. So I zoom on the two patterns. There's the hump shape, so like we can see at the top, hump shape that describe an even age size structure. And we can also see a reverse J shape that can describe an uneven age size structure. At the bottom right, we can see that uneven age stand, it's the pit in blue, are older growth compared to the even age stand that is named hump in red. So we then use the parameter of the quadratic equation, so the quadratic coefficient and the linear coefficient, and put them in correlation with the mean serotiny. So the quadratic coefficient is the second slope in the pink, and the blue is the linear coefficient, the first slope. So that's the result. So we can see at the top the linear coefficient and the quadratic coefficient. So sites with a lower mean serotiny have a negative linear coefficient and a positive quadratic coefficient, so indicating the uneven age size structure and the reverse J shape. In contrast to a highly serotinous stand that have a mean serotiny higher, they have a positive linear coefficient and a small negative quadratic coefficient, indicating the even age size structure, so a hump shape and no regeneration. We can also observe at the bottom left the number of seedling and sapling. It have a tendency to be smaller when the mean serotiny is higher. So when the mean serotiny is smaller, the stands are less serotinous. There are a higher number of seedling and sapling. At the bottom right, we put the coefficient of variation of the ages in correlation with the mean serotiny. So we can also see a tendency to the variation in the ages in the stand to be smaller when the mean serotiny is higher. So a weak serotiny stand will have more variability in the age, so also indicating the uneven age size structure of the weak serotiny stand. So all those results indicate that marginal population of jack pine shows weak serotiny and have high intravariability compared to the stand at the core of the distribution. And without fire, Stand with individual bearing open cone, so weak serotiny, display uneven age structure that indicate regeneration without fire, compared to the high serotiny stand that have less regeneration and are characterized by even age structure. So peripheral population of jack pine seem to persist even if conditions are not suitable with the general ecology, with the general species ecology. So the study opened the door for future research on peripheral population and their persistence in climate change. So like you saw before, our research team is currently investigating the genetic behind the variability of serotiny that we observe in the study. Could it be local adaptation? That's what we are going to find out. So thank you for listening.
Awesome. Thank you so much. I really enjoyed the take-home message. It's very clear.
Thank you.
Do we have any questions for Magali right now? Oh, Maxence has a question. Go ahead, Maxence. Vas-y, Maxence.
Yes, thank you, Magali, for presentation.
Thank you.
Very interesting. But I have some question about the edge structure and the even edge diametric structure. Because in fact, in some jack pine stands that were regularly burned, we observed that they were defined by irregular structure in diameter, but there was still even edge. So I was curious about, because I think about the edge of your stand, you just show the coefficient of variation, but can you show again the link between the variation in the edge and the structure of your stands, please?
I'm not sure to understand everything, but you want to
yes, because I think the figure D is the variation in edge and because I'm just a bit curious about the link between the diametric structure of a stand and the edge structure, in fact, of a stand, because sometimes it seems that jack pine stands can create a complex structure, but because of difference in tree growth rather than tree edge.
Mm-hmm. Yeah. Okay. If I understand, I'm gonna try to answer. If I understand the question. So here, jack pine is expected to, because when we say that they are percent obligate species, they are supposed to do recruitment and regeneration after fire, but there's not supposed to be regeneration without fire because the cone are serotinous. So it's more expected to see one cord like this. And we took the tree size structure because it's easier and faster on the field, and we have a lot of sites than the ages of all trees. So yeah, so when there's a fire, we can see the reverse G shape because there's a lot of regeneration at one time. But if there's no fire, we're not supposed to see the reverse G shape. And here on our site where there's reverse G shape, they're a little bit older because they're on xeric soil. So they're small, but they're really old because they don't grow a lot. Do I answer? I'm not sure where I'm going with that.
Yeah, I think maybe we can discuss that in detail, but
okay.
Because it was a question about this, because in fact, yes, kind of surprising, and sometimes it seems that jack pine can be it can do very complex structure, but the trees are not old, so it can be very surprising. So maybe we can discuss in detail.
Okay.
We have one more question from Yves Bergeron.
Yeah.
Yes, thanks for the presentation. I just wonder if you've observed a surface fire in the stand that you sampled in the south, because if you remember the study by Sylvie Gauthier, where there was this selection for open cone trees, where there were surface fire rather than crown fire.
No, we didn't observe surface fire where we sample our cones. Yeah, no.
Okay, so it was scanned without any fire that
No.
were in. Okay.
Yeah, there were no recent fire, as what we know, and we didn't saw serious fire.